Lesson 7-4, Polynomials. Now a monomial is a number, a variable, or numbers and variables multiplied together. So an example of a monomial would be just a regular number, like 13. It could be just a variable, like x, or it could be numbers and variables multiplied together. It's like 5x, or even 13x squared y. A monomial is the larger name for something that is a term. It's a number, a variable, or a product of the two together. Now in a larger scheme, we have polynomials. Now a polynomial is what you get when you add monomials together. So if you take the 13, you add that with x, and you can even subtract the 5x and add the 13 x squared y. If you put pluses and minus signs between them, that's called a polynomial. It's either one monomial or several of them added or subtracted together. A special name for binomial is when you add two monomials together. So it would look like x minus 2 or say 5 plus y. Two things added or subtracted together that are monomials. A trinomial is the sum of three items. And it would look something like this. X squared plus 5x minus 3. You see you have three monomials added or subtracted together. And those are the terms. A monomial is a single one. Binomial means there's two of them added or subtracted. And a trinomial means there's three terms added or subtracted together. And a polynomial is a name for the entire group. All right, next slide. On here are four different things. Look at each four and decide, is it a polynomial? Yes or no? And if it is, what type of polynomial it is? So pause if you want to try these. Okay, now to determine if something is a polynomial, you have to look at each of the terms. 6x, is that a monomial? Negative 4, is that a monomial? Yes, so this is a polynomial. Now since there's two of them, that makes it a binomial. For the second one, look at each part. X squared, 2xy, negative 7. Do all of those satisfy the requirement of being a number, a variable, or numbers and variables multiplied together? And the answer is yes. And since there was three of them, it's a trinomial. Now when you get to C, and you ask yourself, is it a polynomial? The answer is no, because there's a variable in the denominator. The definition says numbers and variables multiplied together, not divided. Cannot divide by a variable. So the answer to this one is no, and you do not put anything on this line because you cannot be a monomial, binomial, or trinomial if you're not a polynomial to begin with. So again, you cannot divide by a variable. And the last one, this happens to be a single term multiplied together, so that is a polynomial. And the type that it is a monomial because there's only one term there. All right, next slide. We're going to talk about degree now. If you want to write this down, you should pause. The degree of a monomial is the sum of the exponents of all its variables. So you look at the exponent, and that's what the degree is. Short example. X squared. The degree of x squared is 2. That's the exponent. If you have x squared y cubed, add the exponents. Right, that's 5. And then one more. 2 cubed x y squared. It's not 6. It's 3. The reason it's 3, it's the exponents of the variables. So the 1 and the 2 make 3. You do not count the 2 cubed. This is not part of the degree. That is the exponent of a number and not the exponent of a variable. So simply add the exponents for the variables. That will give you the degree. Now, when you have the degree of a polynomial, it is the largest degree of any term in the polynomial. So, if you have this long term, let's do x cubed plus x squared minus 5xy cubed, and then plus 14. Now, each part of the polynomial has its own degree. The degree of x cubed is 3. The degree of x squared is 2. The degree of negative or minus 5xy cubed is 4. And the degree of the number 14 is, since there's no variable, 0. Now the degree of the whole thing, you don't add them up again. You already added the 1 and the 3 together, and that's how you got 4. But you don't add these numbers up. Instead, you look for the largest one. And the one that has the largest number is 4. So 4 is the degree of the entire polynomial. It's the largest single degree. That's the degree for the polynomial. Now up here are several examples. If you want to pause and try to write the degrees for these, go ahead. All right, so what you should have had for the degree of 18 is 0, no exponent. The degree for b, don't forget the 1 from the x, makes 4. And c, since there's only one variable, which is c, it has an exponent of 1, the degree is 1. As for d, which is a polynomial, each part has its own. 0 for 12, 1 for 5b, b and c make 2, and b cubed makes 3. Whichever one is the biggest is the final answer, and that's 3. 3 is the degree for the entire polynomial. And lastly, e, 2 for 9x squared, 1 for negative 2x, and 0 for negative 4. So the degree is 2. It's the largest number. Now at the bottom of this slide are some vocabulary terms. If a polynomial has a degree of 0, it's called a constant. If it has a degree of 1, it's called linear. An example of what that looks like is constant is just a number. Anything that has just a plain number is a constant. While a linear means it has to have one variable. So that could be like 5x. Now if you use the name quadratic, it means your degree is 2. So you have to have at least something that has a degree of 2, like x squared. Cubic means there has to be something that has an x cubed. Now there can be other terms, but there has to be something that goes up to 3, just like there had to be something that went up to x squared. So you can have other terms, but you have to have something that makes it squared. Quartic is when you have an x to the 4th. And again, you can have other terms, but you must have a 4th being the biggest. Quintic is for 5th power. And again, you can have other terms, but you don't have to. And then once we get above 5, we don't have any special names. We use 5th degree, 6th degree, 7th degree, and so on. But those are the special names based upon a monomial's or a polynomial's degree. All right, last slide. Standard form. Standard form of a polynomial. Now we've had standard form with linear equations before, but this is standard form with a polynomial. It's when the terms are in a certain order. And that order is from the greatest degree to the least degree. So the biggest degree goes first, and then the smaller degrees in order go down. Now a leading coefficient is the coefficient of the first term. Whichever term is in the front, when it's in standard form, that number in front of the variable is called the leading coefficient because it's the first thing, it's the leader. Now down here are 2 examples. And what we want to do is reorder the terms and put this in standard form by degree. So take a look at A. The one with the biggest exponent is the 3x to the 6th. So it needs to be the first term. 6 is the biggest exponent. Following after that would be the 9x squared. And then the third and final term is the minus 4x. If you notice, the degree goes down. It goes 6, 2, 1. That's going down the whole time. That means it's in standard form. Now the leading coefficient, which is to abbreviate that LC, is the very first number in the problem. And that's 3. All right, if you want to try B, go ahead. Now I'm going to do it. So I'm going to look at the degrees. 0, 1, 2, and 3. So this one is completely backwards. So I'm going to reorder it and put the 8xy squared first, the 6xy, then the 5y, and lastly the 12. And then the leading coefficient is the number that comes first, and that's 8. So standard form has the biggest exponent first, going down smaller as we go, with the leading coefficient being the first number. All right, this finishes up 7.4, the introduction to polynomials.